Okay, so last video for chapter 13. So good news is we only have 3 videos for chapter 13. This last video, though, is probably going to be a little bit longer, but it doesn't really make sense to break it apart. Okay, so now we're going to start to talk about probability models and kind of basic probability rules that always need to be followed. Okay, so we use a simulation to imitate chance behavior. Fortunately, we don't have to always rely on simulations to determine the probability of a particular outcome. Descriptions of chance behavior contain 2 parts. There's the sample space of a chance process, which is the set of all possible outcomes, okay? And then there's a probability model, which is a description of some chance process that consists of 2 parts, the sample space and the probability for each outcome. So a sample space can be very simple or very complex, right? So when we toss a coin once, there are only 2 possible outcomes, a heads or a tails. We can write the sample space using a set notation just with set notation such as the sample space is equal to the possibility of a heads or a tails. Okay. When Gallup draws a random sample of 1,523 adults and asks a survey question, the sample space contains all possible sets of responses from those 1,523 people out of 235 million adults in the country. So that would be a situation where your sample space is actually extremely large and very complex. So each member of the list it lists the answers from one possible sample, which explains the term sample space. So let's look at an actual sample space. Okay, so many board games involve rolling a dice, right? Imagine rolling 2 fair die, 6-sided dice, one that's red and one that's green. Okay, here's your sample space. So there's obviously 36 outcomes in rolling 2 dice. If the dice are carefully made, all of these outcomes have the same probability. So a probability model. So each outcome that is equally likely to happen. Each outcome has a probability of 1 out of 36 possibilities. So a probability model allows us to find probability of any collection of outcomes, which we will call an event. So an event is any collection of outcomes from some chance process. That is, an event is a subset of the sample space. Events are usually designated by capital letters like A, B, C, and so on. So if let's say if A is an event, we write its probability as P of A. Right? So in the dice rolling example, suppose we define A as being the sum of is 5, right? So there are 4 possible outcomes in that event. Okay? 1 on the red, a 4 on the green, a 2 on the red, a 3 on the green, and so on. Okay? Because each of these outcomes has a probability of 1 out of 36, the probability of A is 4 out of 36. So suppose event B is defined as the sum is not 5. Then what would be the probability of B? Well, if the probability of everything for it to be 5, the sum of 5 would be 4 out of 36, okay? That means that there are 36 total outcomes minus the 4 that would be 5 means that there are 32 out of 36 that is not a 5. Okay. Let's talk about one more possible idea here. So let's say we have one more idea here, right? Let's talk about C being the sum of 6. The outcomes in C then could be a 5 on red and a 1 on green, a 4 on red, a 2 on green, a 3 on red, a 3 on green, and then kind of flipping it, right? 2 on red, 4 on green, 1 on red, 5 on green. So that would mean that there are 5 possibilities of getting a sum of 6 out of 36. So now if I asked you guys for the probability of A and C, okay, so the probability of the sum of, actually not, and, the probability of A or C rather, we're not quite up to an and yet, the probability of A or C, so it's the probability of the sum of 5 or the probability of the sum of 6. So because these two events have absolutely no outcomes in common, we can add the two probabilities of the individual events. So the probability of A happening plus the probability of C happening. So that means that we have 4 out of the 36 plus 5 out of the 36. So we have a probability of 9 out of 36 for the die to roll either a sum of, or the die to roll either a sum of 5 or a sum of 6. Okay, so these are some really important but just basic rules of probability. So we're going to get obviously more complex than this, so we have to kind of understand the basics before moving on to that. So the probability of any event is a number between 0 and 1. So the probability of an event is the long-run proportion of repetitions on which that event occurs. Any proportion is a number between 0 and 1. So any probability is also a number between 0 and 1. An event with probability 0 will never occur, and an event with probability of 1 will always occur on every trial. An event with probability of 0.5 would occur half the trials in the long run. All possible outcomes, second basic rule, all possible outcomes together must have probabilities that add up to 1. So because some outcome must occur on every trial, the sum of probabilities for all possible outcomes must be 1, exactly 1. If all outcomes in the sample space are equally likely, the probability that an event occurs can be found using the formula that the number of outcomes corresponding to the event will be put over the total number of outcomes in the entire sample space. Probable to total. The probability that an event does not occur is 1 minus the probability that the event does occur. If an event occurs in, say, 70% of all trials, it fails to occur in the other 30%. So the probability that an event occurs and the probability that it does not occur will always add up to 100% or 1. So that explained why the probability of the sum isn't 5 was 1 minus the probability of the sum is 5. So it's probably easier to figure it out in some situations. So we refer to the event not A as the complement of A, which is denoted by A to C. If two events have no outcomes in common, the probability that one or the other occurs is the sum of their individual probabilities. So if one event occurs in 40% of all trials, a different event occurs in 25% of all trials, and the two can never occur together. Then one or the other occurs 65% of all trials because 40 plus 25 is 65. So when two events have no outcomes in common, we refer to them as being mutually exclusive, which can also be called disjoint events. They can never occur together. There's no overlap. It's pretty much the same thing as the last page, just kind of more symbolically. Okay, so just one last example and then we're done. Distance learning courses are rapidly gaining popularity among college students. Randomly select an undergraduate student who is taking a distance learning course for credit and record the student's age. Here's the probability model. Okay, so from 18 to 23, the probability was 0.57, 24 to 29, the probability was 0.17, and so on. So let's show that first, this is a legitimate probability model. Well, that's fine. Each probability is between 0 and 1, okay? And the other thing is that all of them added together has to total 1. And then the second question, find the probability that the chosen student is not in the traditional college age group, so 18 to 23. So you're just going to subtract, right? It's the probability of not being 18 to 23. So you have an option. You can add 0.17 plus 0.14 plus 0.12, or you could do 1 minus the 0.57 that represents the traditional college age group. And that is it for this video. That is it for chapter 13.